Okay, so let's start. So I'm going to talk a little bit about Perceptron just because I'm using this term here. So the title of this meetup, what is multilayer Perceptron, which is more like multilayer neural network. There are some differences between them. If I talk too fast, just let me know. TensorFlow, what is computational graph? TensorFlow, what is multilayer Perceptron with TensorFlow? I'll show some graphs or figures that Tensorboard is another tool from Google is generating for training that you want. Two code examples, one for the multilayer and one for Tensorboard. Depends on our time, okay? And of course, Team is in. Give me 1 second to have Team connected. Okay, that's the virtual thing. Let's see. Okay. Okay. Found it. Okay, I think he's going to join us soon. Okay, so what is Perceptron? Perceptron is basically an algorithm to classify for binary classification. I don't know. It could be any field. This is field of dogs and cats. So the distinction between dogs and cats, if it's in the healthcare industry, might be sick and healthy, or it could be, I don't know, to other items, chairs and tables. And here what you see in these specific figures that we're taking for Wikipedia is how the distinction, the hyperplane is being changed by the number of, do we have Team inside?
Yes, I'm here.
Okay, great. So you hear us?
Yes, yep.
Okay, we just started. You haven't missed anything. This is the first slide.
Yep.
And this is being recorded and might be published on YouTube channel. So if you have any concern with that, just let me know and I'll make sure not to publish it. Right now it's a private meeting, okay?
Okay, great.
So, so here we see how we distinguish between dogs and cats, and sometimes there is some payoff that we pay when we distinguish between when we don't have the exact features that distinguish between the two. And also, guys, could you mute yourself? I hear someone, probably others hearing this. Mute. And this is a linear distinction, so we don't have any curves in the hyperplane. It's two spaces of dogs and cats. Okay. So if you look at perception computational graph, we'll see the input. It is the samples, the dogs and the cats that we are feeding the system. We have weights that we want to adjust in order to be able to distinguish eventually between dogs and cats. Here, the one So if we take a very simple example of this, it would be the linear function, like y equal ax plus b. So this will be the a, and this will be the x, and this one, the one will be the b. Okay, so this is a scalable version of a linear function, I assume. And once we have the output from this, from ax plus b, or in this case, xw plus b, then we enforce activation function on it that I'll show a few examples of activation function, and then the output will be dog or cat. It's a one output in our case because it's on and off. So one of them will be dog and one of them will be the cat. Activation function is a function that take the result that we have here and make a very blunt distinction. If the value here is greater than 0, then the assignment will be of 1. And if it's lower than 0, then the assignment will be -1. And that will be correlated to the class that we assign to the sample. And there is that we don't see here, and I will mention it later, is the adjustment of the W of the weights. So in the previous slide, the weight, this is basically dependent on the weight, and if we have more samples, then we can be more clear or change the weight in the way that it is presented, and distinguish between the dogs and cats. And therefore, we need to update the W until we get to the point that we feel that the distinction is in a. Okay, what is so slow? So the samples will look like something like a matrix of samples and features. Features could be anything that you can that is included in a cat or in a dog. Could be the feather, the eye color, anything, the shape, the pixels of the picture, anything that you can think about. The weight will be a measurement that the value will reflect how much this feature is critical to distinguish between a dog and cat. Okay. And then once we make the matrix multiplication between the sample and the weights of the sample, then we get this input value that is being pushed into the activation function. Sorry. And here we see the full process of what is happening, and another figure here that present the activation function. So activation function could be like a step here that is assigning 0, 1, could be assigning -1 and 1, or linear like that. In Perceptron, we are talking about this kind of activation function. In neural network, we are talking about many others. This is more like a discrete values, and sometimes we use more like a sigmoid function or others. But for the concept of the things that what I think is important to understand, that they have a sample with a lot of values for the features and values for the weights, and once you get their multiplication, then you enforce the activation function and have the result for the classifier, whether it's 1 or 0. And in Perceptron, we are updating the weights to the optimal weight that is relevant for distinction. In neural networks, this part is different. calculating loss and accuracy that is based on the difference between the predicted value and the computated value. I will not go too deep into that because it's a more high level to understand how the code is working. But if you want more resources that I can send you, the distinction between them, other than here you don't have any depth. It's a one layer. Okay, and this is the same figure that shows the weight correction samples are being added. So what is a multi-layer perceptron? Or it's more accurate to say a multi-layer neural network is a concatenation of layers from this type. Okay, this is one neuron. We take a sample, we make the calculation here. It's going to be the XW, and we get some kind of a value. Okay. And once we are making a deeper network, then we have more than one until we get to the output of the model or of the training model. Here we are using one matrix of weights. I call it WL1 for layer 1. This will be layer 0, layer 1, layer 2. And here we're using a matrix of weights, which is layer 2. And you can see that each one of them is being, actually I have it in, in this one. Yeah, this one is the one I wanted to show you. So you can see here how the input is being multiplied by the W11 is the matrix of the weight. It's the first cell in the weight, and then W21 and W31 and W41. In the same way that was done for one neuron. The difference between them is other than the hidden layers that we can also distinguish between multiple classes and not only two classes. And the learning method is very much different. There are a lot of limitations to Perceptron. You should be able to know the features in advance. Once you have the feature in advance, there is more chance that you can find the distinction between the two. If you don't have a linear distinction between the classes, it's going to be very painful to work with Perceptron, and you're not going to get the result that you're looking for. It has to be something linear. So that were the things that drove to development of a neural network. Anyone want to ask a question? Because I don't see you, I see the slides.
Can I ask a quick question?
Sure.
Okay, so in looking at this screen, it looks like X1 and X2 and X3 are all samples. So those are part of your training set?
Okay.
Yes. So each one of those is a full sample, right? It includes all the dimensions that you're testing, correct?
Each one of those is a one sample. Yes.
Okay. And so that means that basically you're taking one sample and you're feeding it into this algorithm, into this layer, and the layer is extrapolating whether or not it's cat or dog based on its number of dimensions that are inside of it, right?
Inside of what?
And then what? It's actually taking the weight of each one of those dimensions as well.
Let's go here. So it's doing exactly what you see here. So you have a sample with many features. Features could be any properties. And it's multiplying it by the weight of each feature, how much it contributes to the decision, and we get a value.
Oh, I see. Okay, so it's matrix multiplication to come up with an output that you can score.
Right, exactly. Sometimes you'll see at the literature that they call it S. S is score.
Okay.
Great.
All right, cool. Thanks. That clarifies it for me.
Great. Any other question? Okay. Great. Soon we're going to the code. Yay. Okay, so TensorFlow. Anyone heard about TensorFlow?
Yep.
Yeah, I've heard about it.
One? Okay, so this is library by Google for what they call data flow programming. Data flow programming is because not like in regular programming when you code the algorithm itself. Here you are presenting a graph of how you want the data to flow between the and I'll show it to you in the code, and also the computational graph. You could see that there are like steps that the data is going through. So you are presenting these steps, and then you're running the code and piping the data through the code. Okay, so only at only when you assign a session in Google terms to the code, that's when you are starting the running. There is no running until that point. It's only definition of the process that you're going to run. Okay, and Tensor is a high-dimensional array, so that's why it's TensorFlow. And here we're talking about a lot of dimensions of features and samples. Anyways, I know 2 people were signed up today. Datalab is not a must in this because I will show my Datalab. But basically, if you want, there is a quick video that I captured a few days ago on how to start a Datalab. Okay, I'll show you what it means, and we'll go from there. Okay, so this is an example of computational graph for Perceptron. So we have the X and W and B. This is for the bias. This is the one that you saw that there is the 1 at the weight because it's a constant value. Usually when you go into this scale of data, of big data, the bias is something that is almost redundant. It depends on the implementation. Some people use it, some people ignore it. So it's very much, I think there is some style in it. ReLU and also other activation function that we saw, it's a type of activation function. There is, the colors here are in purpose, ReLU and add and it's for matrix multiplication. This is called operations, is a placeholder. Okay, that's how they call, that's the way they call it. W and B are variables. The reason it's called placeholder is that you're placing the set of training data in it. In the graph, you are not actually giving any value to it. While for weight and for bias, there are tons of research how to initialize them, but even for the only simplicity, you can say you initialize them with 0. Okay, the reason there is a science behind everything is because we're trying to make the learning algorithm train faster. Okay, so there is a data set called MNIST, and I can show it to you. Do you see my screen now?
Yep.
Yeah, you see that I'm clicking MNIST?
Yep.
Share all my machines, so I wasn't sure. So this is the data set basically, and they're trying to distinguish between the different numbers based on the handwritten, the people that, it's handwritten digits that we're trying to classify based on machine, with TensorFlow and deep neural network. Okay? So, I go back to my slides when I find them. So we have 10 classes because it's 0 to 9, where we are going to define a multi-layer graph with 2 hidden layers of size 256. I'll show you the code in a minute. And we define the method that will be used to update the graph, like what loss function we want to use and what optimization we want to use. Basically, it's I'll call it a game, but it's between, okay, let's start from that. Loss is the difference between the calculated value and the label of the data. Okay, let me go back for a second here. The label is a new term that I'm presenting, and I want to make sure I reviewed it. When we give the input is a set of two things. It's the features of the samples and also the label. So when I'm training the model, I'm training it with this is this sample, all the features that I know about it, and it's a cat. I'm telling you in advance it's a cat. Okay. And the same I'm doing for the next sample and for the third sample and for all the M samples that I have. When I'm training the model, part of the samples are going to be left outside. And I'm going to ask myself in every training iteration that I'm doing when I'm improving my weights, was I able to predict the labels correct for the piece that I left outside? Okay, let me just, because we're on the internet here, training, validation, and test. Okay, great. So we have the training data, okay? It's all our samples, and we have the testing set of data. Okay, when I'm working with the training data, I'm splitting the sets to training and validation randomly. Sometimes the validation is going to be here, sometimes it's going to be here, sometimes it's going to be, I don't know, 10% of all the data from the training randomly selected. Then I train the model on this piece of data and validating. And I'm validating my updated model with the data set that I left outside. And I keep on doing it iteratively. That's basically the method that every deep neural network will do it. This testing set is something that you leave really before you ship your product in some ways, or you blindly doing it at the end when you think you finish working on your model and now it's the time to see if for a fresh you are able to predict the right class. Am I clear?
So you,
guys?
you leave off part of you when you take the original set of data, you separate it into three classes. One is training, one is validation, and one is testing. And then you iterate through training. You iterate through training and validation as you're going through the process of defining your function. And then when you're done with it and you have the best function you do, then you use the testing to validate it.
Yeah, yes, that's correct. But when you say you're dividing it to three sets, that's the piece that I'm worried about, because the division is here, and then I'm playing with this one, and the validation could be any subset from this set, and I'm doing it more than once. It's called like cross validation. Let's see if I see. Yeah, this one. You see this one?
Yeah, I do. Okay, I get it.
You get it? So then we can decide. There is also tons of research about how much do you leave for training and how much you leave for testing. Used to be in the past that they were doing 20-80. These days, they are not always doing it like that. Also, the machinery has improved, and the amount of data is very much affecting the way you do it, and the distribution of the data that you're taking is also affecting the way you do it. But I'm just giving you, like, I'm dropping this information, but the information that is really important is the high level here, is to know that there is piece of type of data that you're not touching.
Hold out, okay.
Exactly. And where I was explaining the code, and the reason I'm showing it to you is because it will be easier to understand the code once you understand the motivation behind it. Okay, so what is loss? Because we gave as an input the samples themselves and the labels, right? We know if it's a dog or a cat at the training data. Then when we are updating the weight, we're trying to minimize the loss. Make sense?
Mm-hmm. Yeah.
Okay, so we're trying to minimize the loss, and the other thing we're trying to do is to do it as fast as we can. Because compute is very expensive, big data, you make them mad, the people tried, and also optimization can make it go down from months to days if the optimization is super, super good. So there's a really good reason to make effort to make a good optimization. So I'm going to take you to my Datalab, and I'm going to also give you the GitHub that I'm using so you can. So for anyone who is not familiar with Datalab, anyone who is not familiar with Jupyter, so Datalab is a way to run a code in a very interactive way. For people who were doing code in the old eras, like me, we used to compile and then run the code, okay? Nowadays, we can write like a script language. Let me see how much CPU do I have here. Okay, good. We can run the code just after we wrote it, and if there are some variable in the system, in the environment, then we can use them. If not, we can define new variables. I'll show you it in a minute. Okay, so this is my machine. This is my Datalab machine. And I'm going to write Datalab connect. I'm going to connect to this machine. And if Google will be nice to me, it will happen fast. I have on my channel, meanwhile, until it's running, if I go to my channel, I have the link in there. Okay, this is the one. So I created here 8 minutes because I was waiting probably for Google, but it's a few minutes. It's a few minutes practice how to start a Datalab. Once you start it, once you create it, you can connect to it the same way I'm doing right now. Okay, so I connect to my Datalab. It's on my local host 8081. I just click on it or go from here. Change port, the default is 8080, so you go to 8081. This is another way. It opened here a browser of files, and this is the 2 files that I made for you. One is the Perceptron, and the other one is the Tensorboard that I talked to you about. I'll show you soon.
Yeah, I'm very curious to see the notebooks.
So this is, okay, yeah. So this is the list of the notebooks, and this is the notebooks themselves. And you have notebook open?
I can open it again. When I ran it, I typed the same thing as you, but it didn't do what yours did. So
you can share your screen, and this is a good practice for the class.
Oh, okay.
Okay.
All right. Just give me a second. I'll load it up. And I'll open it.
If there is anyone else who wants to show anything in his notebook, you can do that.
Yeah, I just lost the connection again, so I'm just reconnecting to the notebook.
Okay. If needed, we stay longer, so we will review all the code. The code is not too long, so if anyone is restricted with time, don't worry.
VM instances. Almost there.
No problem.
Yeah. And then, all right. So
do you know how to share your screen? Great. So the way you should share your, great. Yes.
To share it, yeah, tell me how, and I'll share.
So on your left, there is this, you see my screen, there is this green arrow, and it is screen share. And that's the way to share.
I guess people are seeing me now?
Yes.
Okay, so I'm right here. I have my VM instance, blah blah. From here,
It's turned off. Can I see your VM instance? It's wait, no. Go back to the here. Why are you jumping?
sorry.
Yeah, this one. Can
Yep.
you click on start? It's not started. Great. It's basically when you create a Datalab, it's create on the background the virtual machine and connect this. By the way, you can connect it to GitHub if someone is interested. I'm not doing it, but you can do it.
I think.
So it's So it's generating a machine for you. Anytime you connect, I think I recommend it because I do it is shutting down the machine when I don't use it. The reason is Google is charging you. Google is charging you for that. It's just money wise. So
yeah, that's
if
why
you have tons
it
of
was
money,
off.
yeah, great. Another thing that you can do is also change the CPU to a smaller machine. If you use a very large machine, change it to smaller machine, and then even for idle machine, you pay less.
Okay, so it looks like I connected like that.
You're using SSH?
No,
No, I don't think you want to use SSH.
I
don't think you want to use SSH.
Yeah, I don't think so.
Can you show me? Yeah. Okay, go back to the machine. Why is it jumping?
I'm staying still.
Yeah, I don't know why. Yeah, but it's jumping. Okay, so turn this one off. Close this.
Turn it off?
Yeah, and show the machines. And I'm using Python, I don't know, 2 or 3, we'll see. I'll probably use Python 3. But can I see the machine again? I don't know why I see that. Maybe I need to click on your, I'm seeing my sharing.
Oh.
Okay. So your machine is starting right now. It's not started yet.
I hit stop because I heard you say hit stop.
Here you. I'm sorry. I think I got confused for my machine.
I believe
so while you're starting it, there is another one who wants to ask question?
Yeah, sure. Someone else go.
You started? Yeah. Until it's going to start.
Otherwise.
That's a compute engine?
Yes, that's exactly. Compute engine is a machine. It's a virtual machine instance.
So when you sign up for the 1 year free trial, do they care what size VM you have or number of NIC cards or whatever?
Do they limit? What was the question? Do they limit?
Do they care? Because it's a year free.
No, they don't. No, because it costs you money. The only thing that they won't give you is a GPU.
The only thing they won't
or
give
very, very large machine. Is a GPU or machine with 16 cores or something like that for the trial. But for whatever you use, if it's a normal, advanced even use, you can use this $300 for, it's either $300 or 12 months.
Oh, I see. Okay, I see what you're saying. I didn't understand that. I thought it was just a year free, but it's an or situation kind of thing.
Yes.
It's
yes.
$300.
By the way, you're creating machine. You're not connecting.
I know. I was just going back to scratch since the other one was being annoying.
Okay.
Sorry. Yeah.
So okay. So might keep on doing that. And who it was Dave?
Yeah, that was me. I'm building a compute engine right now. It's taking a few minutes.
Yeah. Yeah. Okay, guys. So let's review the code because Emma is super nice, and I will review each one of your machines. By the way, yeah, this means that you need to wait a little bit longer. You don't see yet the message that tells you the machine is ready. Okay, you see my screen?
I think I need to stop sharing, so I'll go wing over there.
No, if you click on my square, on my name square, then you can see my screen.
I can see your screen.
You can keep on sharing if you.
Oh,
okay, great. If it's jumping between the screens, it's because either we're both talking or maybe the clicks, I don't know. Okay, so what do we have here? So Google prepared MNIST for us as a data set, and also all the division between the testing and training is ready for us. They made functions ready for us, okay? So we can concentrate on the logic itself of TensorFlow, and if you want, we can drill later to what they were implementing there. So this is a Python way of writing. It's TensorFlow is very Python oriented. I don't know. So we import the input data for the MNIST. The data to be one hot. One hot, it means that whenever you have the label assigned, it's going to be one. It's going to be vector of 10 items. Let me show you what is one hot. One hot vector. The class is 0, only the one is on. The class is 1, only the one, the next one, because this is 0, 1, 2, 3, 4, 5, 6. You understand?
Yep.
Okay, great. So that's exactly what they were asking here at the code. It's style, but many times people use that for classes.
Can I ask a question?
Sure.
So in going through that tutorial, it looks like there's some utilities, like Google does some of the data importing for you in that input data.read data sets. Is that right? I guess one thing I'm curious about is how to import some arbitrary other data set I have.
Okay, so a few options. Where is your data located?
Let's say it's located locally.
Okay, so if it's locally here specifically, what you can do, you can, I'll show you now.
Or I guess, is there any sort of manipulation that needs to be done to some,
So
I don't know, CSV of features?
I'll show you the okay. I'll show you you can upload the file here, okay? There is a manipulation, but it depends on your data. Usually the data will look something like that. It will look like a matrix when you have the samples and the features, and you have one column of the label or another place where you have a vector of the labels, which means the classes. Make sense?
Yep, that makes sense.
Okay, I can also show training, but it depends on the way you are implementing that. If you're using TensorFlow, then TensorFlow asks you to push the data in some way. But let's see. But here they many things are already. So this is example, okay? Sample is a user. This is the features. The only thing that I don't see here, and you will need, is the label, another column with the class.
Okay, and then is there a preference for how that's how that matrix is oriented? Like, should samples be the rows or the columns?
So
or
it depends. Only it's not that no. When you multiply the matrix, then you need this, because the dimension of the matrix needs to fit. So if you make the table in one way, then you can transpose it. Okay.
Okay.
Because it makes sense, because matrix multiplication is something that you're familiar with.
Yep.
Okay, great. So that's the thing.
I'm sorry, you're transposing the same file? You're actually taking a file that is on temp data, right? And then you're transposing it and doing matrix multiplication with the same file?
So we are not transposing files, we are transposing tables, right?
Sure,
So-
sure. File being a table.
Okay. Yeah, okay, so that's fine. So if we take the input data and your data specifically is oriented 90-degree, okay? The
Okay.
sample is not the, so then you can transpose it when you push it into your model, into a training model. I can show you here the data. We'll run it and I'll show you the data, okay? So when you run something on a cloud Datalab, it's like IPython or Notebook, you can hit, I know on Mac, it's a shift return, okay? Once I run it, you'll see a blue, once it's complete, you'll see a blue line here, okay?
So
See this?
shift return caused that to run?
Yes. And you don't need to make sure that all your code is, talking to each other and there are no bugs or something like that. This piece is done. Okay. So what we can do here, you have the MNIST data. I can add another piece of code here. Okay. And I think this is, let's see, what is this type? Data set. I have no idea what properties does it have, but what I can do is hit the point here, and there is count in the place validation. I don't know. No, it doesn't let me. I don't know. I can look later how we can look at the data and see what is how it's oriented. Okay, but because I'm not familiar with this data type exactly how to put. Maybe we have it in the later one. Okay, so learning rate, training epochs, batch size, and display step. So we'll start with batch size. Batch size is the size of the data in the training set when we cut it to more than. When we look at the training and validation, do you remember that you have a few squares in the training? Okay. You remember this one? Or that one?
Mhm.
Them could be a batch that you are training on instead of training on everything together. Why do we do that? It's part of the optimization of the process. Sometimes you figure out that your accuracy is so high and the loss is so low that you can stop the training and not keep on training on the rest of the data because the trade-off is doesn't worth it. Okay? Or you get to the 100%, which is rarely happen, of accuracy. But if you get to very high accuracy, you might decide not to keep on training. So that's what we see. This is the batch size. The display step is when do we want to show? It's printout parameter. Training epochs. This means how many times we want to review all the data here with different cross validations, okay? And learning rate is what change do I want to do to my weights based on my loss, based on the difference between the predicted and the calculated value. And we'll use them soon, so it might make more sense. I'll keep on with the initialization. On the first hidden layer, I want to have 256 neurons. On the second one, I want to have another 256 neurons. The input size is going to be 784, the size of the vector. It's the picture of the digits. and the number of classes I'm going to use is 10. Okay, so I'm running that, the initialization. Now we are building the graph. Okay, placeholder is the X and the Y. X is the input of the training data with all the feature, and Y is the label that assigned to it. The label is the class, is another name for class. So this is 0 to 9, it's going to be 10 classes, and this one is going to be a placeholder for the input. I can show you the input later on. When we run it, I can try to print something. The weights for each one of the, so if we go here, back here, so for the, I want to define the weights for this layer and for that layer. Okay, it's very similar to what you see here. We have the placeholder X, that's what's coming here, and we don't see it here, I don't know why, but there is the Y will be the assignment of each one of them to a cat or a dog. Or in our case here, it's going to be for 0, 1, 2 till 9. So these are the weights. They decided to initialize the weight with random value. There are many ways you can initialize all zeros, random normal, or if you look at TensorFlow, there are many options for initialization. So you see random gamma, random crop, normalization, Poisson, shuffle, uniform. You can play with that. It's a different kind for initialization. The reason to do it is to get closer to the real weight or to the weight that will give you the best accuracy. And the biases are also initialized here. It's basically a vector of a constant value. So I'm running it. Okay, this is the definition of the multi-layer perceptron. Layer 1 will be a matrix multiplication of X, okay, and weight age 1. This is this one. And we're gonna multiply W by X and add the biases of B1, okay, this part. So basically, this weight and this bias is used for the first layer. This is the first layer here, to generate the first layer. And for layer 2, we're going to use layer 1, the information. Layer 1 is input for the layer 2. The weights from age 2, this one, and the biases B2. Guys, am I going too fast or it makes sense? The output layer will be the matrix multiplication of layer 2, the weights for the output, and the biases for the output. And by that, we build something like that. Yeah.
Yeah, so in this scenario, there's only 3 layers?
Yes.
Okay.
But I can tell you that Google created an API that is higher than that, like higher level API that you are less dealing with the details. And in this case, you will not need to define the weight and the biases for each layer the same way. I don't think it's not a good place to start with, but it's a good place to use. You know, it's a good API to use. I think it's called Estimator. It's on top of layers. They have few.
Okay.
Okay. So yeah. So we're using right now the Python frontend TensorFlow here. This area. You can go up to layers and then estimator and canned estimator. Honestly, I haven't used. I used estimator and layers, and they are fantastic. But for understanding first how you build a computational graph and where you can heat issues, this is I think good place to start.
Can you say? Can you show me where the nodes were declared again for each layer?
The nodes.
Yeah.
So you mean this is 256?
Yep. That's what I want to know. Yeah.
Okay. Okay, great. Okay, so now we are constructing the model. Nothing was this is data flow, as they called it, because we are defining here the data flow and the computational graph, but we haven't ran anything yet. I mean, we ran initializations, but we haven't ran model training yet, okay? We are defining the loss. The loss will be soft macro. It's basically a way to subtract the label y that we gave as an input from the computational label that was generated by the model, by the training model. Okay, there are many loss functions that can be used. Everything you can search and Google will give you tons of data, but just so you know, there is I don't know. There is a lot of way to calculate loss. The idea behind it is some kind of Euclidean distance or square distance between two values. Make sense?
So that's your minimization function, right?
That's not a minimization. That's right now defining what kind of loss function I'm going to use. Okay, reduce the mean. Loss is the mean from all the samples that you were using. Okay, I'm going to show you graph of loss function for the execution, but loss function, machine learning.
So in many ways, this is like the classical neural network, except at the very end, or you said there was a differentiation between this and
this is Perceptron?
Yeah.
So no, this is the neural network. Perceptron is using something else. It's using the weights to reduce the loss, okay, to reduce the differences, and it uses the weights only for the samples that were not predicted correctly. It's a different way of calculation loss, but and I can send you some information about that. It's not being used because there is a very limited things that Perceptron can do, and for Perceptron, you need to know in advance what features are the right features for prediction. While in neural network, you can make a feature selection or some kind of feature reduction while you are training. It's called regularization.
But for perceptrons, if you know your classes, you would go with this approach because it's faster.
Yeah, like updated Perceptron. The Perceptron was invented in the 1960s, or maybe earlier than that. Maybe I don't call me on that, but it's something that was created long ago. Tell me if I'm Googling too much for you. Well, yeah, probably 80s. Okay, at that time, yeah, 1950s, yeah. It's close. But Perceptron is calculating the loss differently, and it's not what it's used right now. So it's good to know, but it's not what is being used right now. It will not give you immediate tools to work with. Okay. So here I'm showing you a graph that shows you the loss as dependent in the epoch. How many times I trained and how the loss went down. So here you can see how the loss went down while I was training, and this is the trend that you want to see. If you see that the loss is going up, of course, you're not training very well. If you see that the reduction is very smooth in some way, there is no like critical reduction, then you want to make sure your optimizer is working correctly or something in your code is not working that you can improve. Okay, and here it just staggered. So you want to find something with less plateau, that the plateau is coming when the loss is very low. Okay.
I have to drop, but thanks so much for hosting us.
Okay, I'm sorry, you have to go there. Okay,
Great.
so I'll send you, and probably it's going to be online, so you can, if you want, learn the rest of it.
Okay, yeah, sounds good. Thank you.
Great. Bye. Okay, thank you, Emma. Okay, so let's run this one and move on. I also noticed that it's 8:10. I did notice it while I was enjoying with you guys. And now we are assigning the session to the graph. So we're actually running it, okay? And we're running it for every one of the epochs that we were saying. We want to divide the data to the batch size, okay? The number of the examples to the batch size, and then for every batch, we want to, this is batch, we want to init the x and the y of the batch. So it's subset of the x and the y, the one with all the data, with all the training data, and we want to run our model with the subset of x, subset of y, and get in return, this is the loss of the training. What do we see here? Every epoch, we want to, this is the display step that was 1. So every time that we divide by 1, we have the modulo. So every time, every epoch, we want to print what is our cost and what is the reduction in the cost. And this is the test model after we are done. By the way, Python indentation is a scope. So the 4 is ending here. Sorry, here, okay? It's like, I don't know if someone used from another language. So Python does not use that. The way to define scope is just to indent the code a little bit. So this is everything that happened at the for loop when every epoch we train the model. And then we check on the test data, what is the accuracy of the prediction. Okay? So I'm going to run that, and you will see how the code live is if I run everything. Yeah, I run everything before. So you see the epoch 1, the cost is 302. And then epoch 2, after one adaptation of 256 and 256, remember, you have neurons, it's 99, and now it's 72. And it's going to run 15 epochs because this was our initialization.
Can you show where you declared the 15 times?
Yes.
Okay.
So we'll see that, and then I'll show you what is Tensorboard, but I'll not go into much details. It was in case after we finish with that.
Is all of your code located in this one lab?
No, actually, this code is. I'll send you the slides, but it was it's this person works for Google. The other code that I wanted to show you with the Tensorboard, I'll show it to you anyway, and I'll send you the code because it's very similar. It's less deep, but the idea of the code is different. It's less deep, I mean the network. And you can play with that and see the loss and accuracy of the code. Okay, so the accuracy that you get is 88%, okay?
And
after 15 epochs.
And then it used your data that you have put on the side to run in order to get that number.
Yeah, this is from the test data.
Yep.
Okay, because this is the test. Okay, I want to show you another thing before. Okay.
I'm just thrilled to see it run. I'm like,
Okay. Great. I felt like I tried to give you so much in so little time, so I was worried that you were overwhelmed
no,
from the amount of it.
I prepared. I looked at what you told us to do. I've been working out all the math and stuff, so it's okay. It's all gelling for me at least.
Okay, great. Great to hear that. So the next thing is to see the loss and accuracy on Tensorboard. This is a tool from Google, a fantastic tool. This one is something that we are going to generate soon in a minute. So basically, you see how the loss is going down, and then the accuracy is going up. This kind of staggering here, or this kind of oscillation, is basically part of the batch usage, usually. It's the trade-off that we pay for getting faster to the higher accuracy. I mean, I don't know if it's a payoff, but this is when you use a batch, then it's going to happen. Again, there is a tons of theory on that. I'm happy to review it with you in the next meetup. But first, let's see how we generate this kind of graph, which is kind of cool. So, and this is the computational graph. Another thing that Tensorboard will do for you. Okay. So you will see here, it doesn't matter exactly. It's not the same like we did. It's a weight and the bias. This is the input data. You go into the model, you generate accuracy and loss, and you do stochastic gradient descent loss calculation. It's based on derivation of the features. Doesn't matter. This is part of the loss calculation. But here you can see the computational graph, which is very cool, I think. And let me start this for you. This is the logs from this Tensorboard. Let me start it for you and run it, review it with you quickly. Okay, so you see, I will review it with you. It's the same idea of running a model 25 times this time, but the cool part is that we can see, and I'll show you. So it's the same idea. It's an MNIST score. There is learning rate that we are using to adjust the weights. There is a training epochs, batch size, display when we want to print. And I added this information. It's based on code that is already available, but I updated it with the place for the log files to be generated for the Tensorboard. And I use it based on the date. So I will not need to every time, date and time. So I will not need to update the code here. And then here you see this?
Yes.
1712. So this is the logs that are, this is the date dash logs, okay? Date dash logs, okay? So this is what I was generating for the Tensorboard. Placeholder for the X and Y, a variable for the weight and bias. Here they decided to initialize it differently. They initialized with zeros here, and it's okay. Okay. And this scope was added because this is the name that you will see on the Tensorboard. You see here model, you see weights, bias. So this is the way that we're here at the code were assigned. Model, loss, stochastic gradient descent. This is just abbreviation. Accuracy. Okay. So this is the name scope is going to be used by Tensorboard. So I'm clicking on that. It doesn't affect the code anyhow. This is right the softmax before it was softmax with course entropy. This is the cost calculation. This is the gradient descent. It's another optimizer. We have many things that we can decide on what to do. At the end of the day, it's going to be optimizer, cost, and loss. Okay. And this is the accuracy calculation. We are initializing here the variables. So basically, all these zeros, TF zeros, were not executed. So once you click that, then they are getting these zeros. Only definition at the beginning before we start running. the scalar and the scalar here is the loss and accuracy that we want to capture for the Tensorboard. Summary is a module for Tensorboard.
Can you show me where the sample input's coming from?
MNIST, same.
Okay, right there.
Okay, so you can review that. It's less deeper. You'll see it also in the Tensorboard, but I do want to show you after it's running what this look like, because it's a tool to help you visualize the things that you are doing with the deep neural network, or you want to change something looks wrong to you, it's not what you meant to do, basically. And it's not straightforward to launch it from a virtual machine. Okay, I couldn't find any place that they will say how to launch it from virtual machine. So I think I published earlier this year a video on how to do it from virtual machine. To you here, because if it's on a local machine, you don't have an issue. From virtual machine, it's a bit different. So the log there is going to be local, like you use in Unix, plus the log path that we defined here. Okay, and then let's run it. And I'm importing the Datalab machine learning library. And I'm using tensorboard.start, okay? Did I run the one? Yeah. Yeah. Now I can start.
Looks like it threw an exception.
Yeah. Okay, so I'm looking at the list of Tensorboard. Okay. I'm seeing one from all time. You see, 1712. It's not today.
That's not 12,
right?
is it?
It's the one that I had here before. As well, 1301. So maybe it is. It is from today. So what I'm gonna do?
Oh, it tried to overwrite a file that existed, so it got mad. Is that what you're saying?
Okay, now it's working. I don't know why. Maybe the log was not created yet. You saw when I click it, the log was populating. But this one was populating, so maybe you couldn't find it. Because there is no problem with opening many Tensorboard. I'll show you in a second.
So when you create the script to go through the iterations for the program, you have to put the output in a certain format, and then TensorFlow, and then the TensorFlow expects that later on, right? So if you change the script, you need to change the TensorFlow input as well, yeah?
Yes, but usually it's a format of a sample and the class that is assigned to it.
Okay, so it's a simple, like it's a
Yes. I'm using it for genomics data. I'm using pandas data frames.
Okay.
I don't know if you're familiar with that. Basically arrays, okay?
Mm-hmm.
And it's straightforward.
Okay.
You can use either one table and point, when you do the Y, point to the column from your table that is the label or the class column, and for all the rest, you can use the samples with the features.
Okay.
And just assign to X the part that is the features, and the Y the part that is the label.
Okay, gotcha.
Okay, but great that you asked question, because Tensorboard takes time. Okay, so you see here the accuracy. So that's what we got. It's a web, okay? It's on the web. We have a loss here showing us the loss going down, okay? showing the accuracy going up. We don't have images, but there is a way to embed the images of the input. The graph itself is the compute graph. It's the graph that was defined at the code, the data flow, okay? And there are many things that you can hook here. So once you start using it, you'll figure out what you need, histogram or other stuff. And you can open it, and you can see. You can see the matrix multiplication added with the bias, activation function of softmax. Okay?
Wow. It's like a flowchart.
Exactly, it's a flow chart. That's, they call it flow, data flow or compute graph. Okay, and then here the accuracy is being calculated, but basically you can see high level. Once you encapsulate it in scope, remember that we wrote the name scope here? So this is the thing that's going to be under this scope, and this is the thing that's going to be under this scope when you open the boxes.
Oh.
Make sense?
So this TensorFlow isn't coming from just the log. It's actually coming from the entire program.
Yes, but at the program, when we wrote summary, it's a log that was created for Tensorboard. Okay?
Wow.
Everything that we did, summary, scalar, if you go to scalar, this is here, it's scalars, you see?
Yes, okay.
So they are attached. And this log, until it was populated, I could not start the Tensorboard. Because this is the input for the Tensorboard.
The input or the output?
No, this is the input. While we are running, we generate it. And then on Tensorboard, we're reading from it.
Okay. Right,
Yeah,
I'm sorry.
makes sense?
You're right. I
Yeah?
was getting confused between input to the program and input to the sensor board.
Okay, it's really confusing. You're right. There is input to the program, you're training. Yeah. Okay. So guys, I think this is all for today. And I would love to hear your feedback, because this is the first time I'm doing something like that. And I don't know if it's too fast, too slow. It's nice that we can Google everything. You know, or maybe we are Googling too much. But you can feel free to write me on the meetup or send me an email and let me know how is it for you.
Well, if you don't mind me chiming in, I'll be the first to say, this is incredibly awesome because, you know, I know just enough to be dangerous, but I think I know a little bit more now to be more dangerous. So my feeling though is that this isn't for complete beginners. You know,
okay.
You basically said, you know, we're going to run a beginner's hands-on session with TensorFlow library in Python. Now, I didn't have the ability. I only signed up for today, so I didn't have the ability to read all the advanced stuff that you handed out or create stuff. So, you know, it might be like, that might be mandatory, but I don't think this would be for beginners. I think this is for people who are probably a little bit more seasoned. And even then I would maybe slow some of this stuff down a little bit.
Okay. And the fact that you can listen to it again, will it be easier for you? Or
Oh, completely.
Okay.
But there are things that I mean, I've learned some AI already, and I already know about the regression analysis and the loss functions and all that stuff. If I didn't have that stuff under my belt, I would have been completely lost, just so you know. Okay.
And the other ones, how do you feel, guys?
So I liked it. I mean, it would have been nice to already have the link to follow through and step through as you run the Python notebook. That would have been nice, but that's something I can do offline. But other than that, I liked most of what was presented, and I think this is more hands-on, doing it over a Hangout as opposed to meeting in person and doing.
Okay, great. Okay, Deb, I won't put you on the spot, but if you want to tell me something, you can email me or you can not, whatever you want.
Well, I thought it was great. I think the only point, I do agree with Dave that I have some precursor knowledge about, you know, the regression and what a neural network's attempting to do, which allowed me to follow along for the specific use case. But with, you know, just a little bit of primer into neural networks, you're basically rolling. And I really liked, I mean, what you've done here is, you know, you're giving us some of the art of refining, and, you know, you might use this for this and this for that. And, you know, there's so much information that can come out, but you're seeing a little bit more of, you know, how to tweak out information out of these things and what's a better use case for this type of data versus that type of data. I really love seeing the Tensorboard, first time exposure to the Datalab. I used your Datalab's video is fine. I just, Google was just being annoying.
Yeah. Yeah, it's not stable all the way. Yeah.
But I eventually got it up and running, but I'm good. But yeah, I really liked that you had some good to go examples. I'm a code guy. I like seeing the code and getting the outputs, and you just gave another tool, Tensorboard, in terms. So, you know, for me, I would love to just go grab this and try to copy paste and run it myself and see if I can't reproduce what you've done.
Yeah, great. So I'll send you the slides. That's great, because you have links for everything. The only thing that you don't have link is for the Tensorboard, because I just generated it. So I'm gonna share it with you guys. And, you know, if you have any idea of something you wanted me to broaden and make, just shoot me an email or write on the board, and I will.
Well, I think Tensorboard was a good lead into a thing that I don't truly yet understand about AI, which is I'm very happy that we created this model and it has this kind of accuracy. How do I then feed it later and get that output into something that a real system can use?
Okay. I can do a meetup on that.
Yeah, I'm very curious about that. Tensorboard obviously leads into it because I can see some of the outputs outflowing, but you know, now that we ran the thing and it's been in quote trained, how do we use it in a realistic setting?
Okay.
How do we tell the difference between a cat and a dog practically?
Exactly. Just, you know, that cat and dog is perfect.
Great. So I'll make a meetup on that. It's much simpler than this meetup because it's basically when you have the results. Great. Yeah.
You'd be surprised how unsimple it is to find on Google. There's a lot of math I can find.
I know. That's the reason I added the Tensorboard.
Yeah.
Because
I'm all over that now.
Yeah.
I can't wait to use it.
Yeah, I was in touch with Google, and they were also having a hard time to help me with that. And eventually, you know, connecting the dots, I was able to generate it. And so I figured out I have to pass the knowledge. Okay, great. So I'll do the distribution and all these model like usage once you have the model ready. And if you have any other ideas, please feel free. I mean, it doesn't have to be now. Yeah.
Do you have a frequency that you're planning of doing this?
So this is the first time I was doing it. I don't mind doing it on a monthly basis or twice a month, but really whatever works for you guys.
Can I make a suggestion?
Sure.
My suggestion would be that you expand this to half a day. I hate to say it. I don't know what your schedule looks like. It might not be practical for you, but I feel like there were so many fundamentals that you could have gone over to make this a little bit more easy, and a half a day would enable you to exemplify this and illustrate it, at least with other people, much easier. because then they'd be able to follow along and do practical stuff. You know, like
Okay. Where are you located? You went online half day?
yeah, listen, I do an online half day, but if it was in class, I'm in Massachusetts, so I would just, you know, I'd go wherever it was. There's plenty of places in Cambridge to hang out.
Okay. No, maybe we can do it also online.
Actually, you can have a Google room if you want in the Google building.
Yeah,
Or,
actually. Yeah. Okay, let me think about. Let's start from the sessions, and I don't mind doing something longer. I'm in Massachusetts, and I can do it too. And I'm next to Google also, so we can. Yeah, we can. Let's have a. I don't know. Let me think about it. I don't want to.
Please do. I hope I wasn't giving you a hard time.
No, you're not. You're not. As long as you like it, and I don't feel like I'm wasting your time, I'm fine with that.
Well, I think what Dave's getting at is if you leave at least me alone with you, and if not Dave, we'll probably pick your brain for the next 5 hours. So he's anticipating monopolizing the conversation such that he gets all his questions answered, and it might take a while for all of us.
Okay, guys, it gave me enough motivation to make the next one. So I hope I'll make it for you soon. And then I would love to keep on hearing your feedback and following your wishes. I'm excited about machine learning. Can talk about it all day long.
Awesome. Thank you very much.
All right. Thank you so much.
Guys, have a good night. Bye-bye. Bye.
All right. Bye.